All right, so here we go, our last installment on factoring. Okay, so far we've looked at factoring out a greatest common factor. If my polynomial had 4 terms, factoring it by grouping. And if I had a quadratic trinomial, can I factor it using the AC method? Okay, the last type of factoring that we're going to talk about is special types of factoring. So is it a special product? So is my quadratic trinomial of a certain form? Okay, or if I have 2-term polynomials, is it a difference of squares, a sum of cubes, or a difference of cubes? Okay, so here's all the special products that we have. Okay, perfect square trinomials have this form: ax squared plus 2ab plus b squared. Okay, or ax squared minus 2ab plus b squared. Okay, so notice the difference between those two formulae are the middle term. One's a plus, one's a minus. Okay, and there will always factor into a plus b squared or a minus b squared. Okay, difference of squares, a lot of you may be familiar with this one already. A squared minus b squared will always factor to be a plus ba minus b. Again, another little note is that it is a difference of squares. If it is a sum of squares, then it is prime. It cannot be factored. Okay, last two special factors that we're going to look at are a cubed plus b cubed and a cubed minus b cubed. So similar to the perfect square trinomials, the formulas are different by just one term, really. Okay, for a sum of cubes, it's a plus b times a squared minus ab plus b squared. Okay, for a difference of cubes, we have a minus b, and again, that middle term changes sign. Okay, so let's first look at these perfect square trinomials. Okay, so again, they have this form, either a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Now don't worry if you don't recognize them, because remember, these are still quadratic trinomials and you could still factor using the AC method. So if you don't notice that it fits this formula, it's really not that big of a deal. Just literally you're saving yourself maybe 30 seconds of time. But it's nice to know, especially with these kind of harder examples that you're going to see here and here, to know this special formula. Okay, but for this first example, x squared plus 4x plus 4. Okay, that is a perfect square trinomial. So my a is 1x and my b is 2. All I did was I looked at that first term and the second term to find what that a and that b are. And now all I'm going to do is fit it into my formula. This is going to factor into x plus 2 squared. And that's it. But again, if you did not recognize this as a perfect square trinomial, it's not that big a deal. You would say, what two numbers multiply to 4 and add to 4? Positive 2 and positive 2. X plus 2 times x plus 2, x plus 2 squared. Same answer, two different methods of getting it. Okay, but again, for the next two examples, knowing this kind of formula is a little bit more helpful. So here I have 25x squared plus 70x plus 49. Okay, so this would be really hard to do using the AC method. You're going to get very large numbers, and it's going to be hard to find those two numbers that are going to multiply to 25 times 49 and then add to 70. So the easiest way to figure out if you have a perfect square trinomial is, again, look at that first term and the last term. If those are two perfect squares, then you got yourself a perfect square trinomial. So my a for this middle problem here is 5x. And my b, if I'm going to match it up with the formula, is 7. Since this middle term is positive, I have this top formula here. 5x plus 7 squared. Nice and easy. Okay, last example here. Again, look at the first term and the last term. Are they perfect squares? Yes, they are. So my A here is going to be 6x. My B here is going to be 4y. Since this is a negative middle term, we have the bottom formula. 6x minus 4y squared. And there's your answer. Okay, difference of squares and sum of difference of cubes. Those are our two-term polynomial formulas. So if I have two terms and both of those terms happen to be perfect squares, and not only that, it's a difference of perfect squares, then I can use this formula a plus b, a minus b, to factor it. So looking at this first example, okay, 121x squared and negative 81y squared, those are both perfect squares, and I have that negative in the middle. So my a here would be 11x, and my b here would be 9y. So this is going to factor into 11x plus 9y and 11x minus 9y. Okay, remember I said this in the previous video, but if you missed that, remember that multiplication and addition are associative and commutative. So I could have also written 11x minus 9y times 11x plus 9y. As long as the signs are the same and they haven't changed, we can switch the order of the factors. Okay, our middle example here, we have 169x squared plus 625y squared. Okay, this is definitely a perfect square. That's 13x, 25y, but notice how we have that plus sign in the middle. We do not have a formula for a sum of squares. A sum of squares is always prime. This can't be factored. Last example, we have 27x cubed plus 64. Okay, so 27 is a perfect cube, so that's good. 64 is also a perfect cube, so I do have a formula. So a, in this case, is going to be 3x, b is going to be 4. So I have a plus b, 3x plus 4, times a squared. So this is 3x squared, which is going to be 9x squared, minus a times b, 12x, plus b squared, which is 4 squared, and that's 16. So I have 3x plus 4 times 9x squared minus 12x plus 16. And that is completely factored.